Welcome to the DIY Honda Garage channel. This presentation focuses on DTC P0705, which designates a transmission range switch problem regarding multiple shift position inputs in the Honda HR-V from 2016 to 2022. The acronym DTC stands for Diagnostic Trouble Code, and it helps mechanics identify specific issues within a vehicle system. In the context of this error, the transmission range switch plays a pivotal role in communicating the current position of the gear shift lever to the vehicle's powertrain control module, PCM. The errors are purely electrical and not mechanical, meaning any issue resides in wiring or connection rather than the transmission unit itself. Diagnosing this issue promptly can prevent further complications in the vehicle's operation. Understanding the causes and mitigating them is essential for optimal vehicle performance. The transmission range switch, identified in error code P0705, is a key component in the Honda HR-V's transmission system, tasked with reporting the current gear position to the powertrain control module, PCM. This device is located near the vehicle's transmission, allowing it to accurately communicate with the PCM, ensuring that vehicle systems receive the correct information for optimal operation. When functioning correctly, the switch transmits different signals based on the gear lever's position, ranging from Park P to Drive D, among others. However, if this switch fails or the circuit experiences issues, the PCM cannot accurately interpret the transmission status, leading to potential drivability problems. It's important to note that any issues causing DTC P0705 are exclusively electrical in nature, meaning there are no mechanical faults within the transmission that would influence this error. Several factors can lead to the triggering of DTC P0705, primarily revolving around electrical issues. Poor electrical connections, which may occur due to corrosion or wear, can impede the signal flow from the transmission range switch to the PCM. Similarly, loose terminals can cause intermittent failures, where the switch temporarily works only to fail again under stress or vibration. A faulty transmission range switch itself is another plausible cause, where internal components no longer function correctly. In rare situations, a defective PCM could contribute to misreading signals from the transmission range switch. Finally, shorted wires that touch ground may also lead to inaccurate readings, indicating an on position incorrectly. Symptoms accompanying the DTC P0705 can manifest in various ways, starting with the triggering of the check engine light on the dashboard, which alerts the driver to a malfunction. Transmission performance issues may arise, including slipping or delayed shifts, that can impact driving safety and comfort. Drivers might also notice incorrect gear display indications on the dashboard, prompting confusion about the actual operational state of the vehicle. In some instances, the vehicle can exhibit incomplete shifts, where it fails to transition between gears smoothly. Finally, the gear selector may become unresponsive, making it challenging to switch between different driving modes, thus affecting overall functionality. The first step in troubleshooting DTC P0705 involves turning the vehicle to the on mode and utilizing the Honda Diagnostics System, HDS, to compare the transmission range switch signal inputs across different shift lever positions. Each of the shift positions, Park, P, Reverse, R, Neutral, N, Drive, D, Sport, L, has defined signal states that should match the indicated values. For example, when the lever is in park, the ATP switch should be on while others remain off. Discrepancies in these expected signals can indicate an electrical fault. It's vital to check the overall condition of the electrical components, looking for any signs of poor connectivity or loose terminals, as this can help narrow down the issue to specific components. In the second troubleshooting step, the technician must once again compare the transmission range switch signal inputs using the HDS while in each shift mode. Ensure that no unexpected signals show an on condition for the switches in all positions. If any signal is indicating on in the wrong positions, it suggests a malfunctioning switch. Documenting these findings is crucial for further diagnostics. If every expected switch output matches the conditions, then we know the range switch is functioning correctly. However, if there are abnormal signals, this directs us to continue investigating the electrical components or the switch itself to identify the fault accurately. For the third step, it is essential to turn off the vehicle to ensure safety and avoid any electrical hazards. After that, disconnect the 10P connector from the transmission range switch. By using a jumper wire, connect the terminal that incorrectly indicates on to body ground. This test evaluates whether the switch can replicate the on signal when directly grounded. Next, the vehicle is turned on again while using the HDS to confirm if multiple signals indicate on when they should not. If multiple outputs are still indicating on, it demonstrates that the switch itself is functioning as expected. Conversely, if signals do not align as anticipated, this indicates that the switch may be faulty and requires replacement. In step 4, begin by turning the vehicle to the off lock mode before disconnecting the 12P connector associated with the AT gear position indicator. This component helps display the current gear selection to the driver. Once disconnected, switch the vehicle to the on mode while monitoring the transmission range switch signal inputs with the HDS. This evaluation checks if the wires between the corresponding transmission range switch and the AT gear position indicator are functioning well. If multiple signals indicate on based on their positions, there is likely no fault in the AT gear position indicator itself. Conversely, if discrepancies arise, replacing this indicator may be necessary to resolve the issue. Step 5 starts by turning the vehicle back to the off lock mode. After securing the vehicle's safety, disconnect the 10P connector from the transmission range switch once again. Power the vehicle to the on mode to check the signals coming from the transmission range switch specifically. This assessment pays close attention to any signals that may remain on, indicating the switch might be inaccurately reporting its position. If it is confirmed that these signals remain on, it suggests that the transmission range switch is operating properly. If they do not align with expectations, it indicates that replacement of the switch is warranted to restore proper transmission function. In the 6th troubleshooting step, repeat the procedure initiated in previous steps by turning off the vehicle for safety before disconnecting the 12P connector from the AT gear position indicator once more. Subsequently, shift the vehicle back to the on mode while checking for signal confirmations with the HDS. It is vital to observe any gear position signals that remain on, which would imply that the AT gear position indicator itself is functioning normally. Should these signals not match expectations, this may suggest a failure in the position indicator requiring its replacement. Therefore, careful observation and analysis are critical in determining the correct course of action. In the final troubleshooting step, turn the vehicle to the off lock mode before proceeding to jump the SCS line with the HDS, which stands for SRS Control System. This action prepares for electrical testing. Next, disconnect the PCM connector B, which is a critical part of the control module responsible for managing various vehicle systems. This action allows for checking the continuity between the terminal of the wire that has indicated on in previous steps and the vehicle's body ground. Evaluating this connection is essential for identifying short circuits within the electrical system that might be contributing to the P0705 error. If continuity to ground is confirmed, then repairs must be made to resolve any shorts. However, if there's no continuity, it implies the wiring is intact, necessitating an update or replacement of the PCM. After performing the necessary repairs or replacements in response to DTC P0705, it's paramount to verify the effectiveness of these actions. Start by clearing any diagnostic trouble codes, DTC, from the PCM to reset the system. Following this, conduct a comprehensive test drive to allow the vehicle to cycle through various driving conditions, assessing whether the error reoccurs. Monitoring system performance at this stage is crucial. Any reappearance of the DTC would indicate incomplete repairs, requiring a reassessment of previous steps. Confirming that all related systems function as intended is essential in ensuring that the issue has been resolved permanently. Completing this verification process effectively wraps up the troubleshooting and repair procedure. Preventive maintenance is vital in existing systems, especially for high-priority components such as the transmission range switch. Regular inspections of all electrical connections can help identify potential issues before they escalate. Similarly, checking the wiring harness continuously for signs of wear or damage can prevent circuit failures. Ensuring that all electrical contacts are clean and free from corrosion is also essential, as dirty connections can lead to inaccuracies in signaling. As an additional precaution, regularly monitoring the transmission fluid quality can help maintain optimal performance. Lastly, staying updated with the latest software versions for the PCM ensures that the vehicle's electronic systems are functioning as efficiently as possible. In summary, DTC P0705 is a diagnostic code that primarily points to an electrical issue within the transmission range switch system. Identifying possible causes such as poor connections, faulty switches, or shorted wires is crucial for effective troubleshooting. Each step taken in diagnosing this issue allows for focused corrective actions, ensuring that all components involved, especially connections to the PCM, are examined. Thorough documentation and validation at each step aid in determining if repairs have resolved the problem. Additionally, implementing recommended preventive maintenance practices can further mitigate the occurrence of similar issues in the future and ensure the longevity of vehicle performance. Please like and subscribe to the channel. See you next time.